Hello, everybody. Welcome, everybody, for the demo session on the Java J2E training that you'll be undergoing. Uh, we plan to start this training today, and we plan to, continue it for the next 8 weeks. I think they are able to listen to me, but they're not dialed in yet. But let's proceed with the training today. Hi everybody, and this is the demo session on the Java and JE training that we'll be having, and for the next couple of months. So it's an 8-week training course with around 1.5 hours to 2 hours every day, and we'll be covering everything from the basics of core Java to enterprise Java and a couple of frameworks like struts and Spring, along with an ORM tool like Hibernate, and these are highly in demand in the market. So that's what we'll be focusing on. There's going to be a highly practical training, and that is why I want all of you to be as interactive as possible. This is not going to be something like a training that you would usually see on, if you just log on to YouTube, you can get a lot of different trainings on Java or Spring or Hibernate. So why not go for that? Why do we have to pay for this? And then this is because we will be having a very interactive session, and we'll be having a very practical session that I'll be writing code and you'll be understanding, and then I'll give you a chance to write code as well, and I'll be reviewing your code as well. And we'll be ending this training with a practical project, a live project, which is actually going into one of our systems. So this is going to be a completely practical training. For all the people who have logged in today, since this is the first time, it would be good that we know each other as much as possible as we go along. So I hope everybody is able to see my screen. Okay, the first thing, this is part of the MindsMap training, and I'm a trainer with MindsMap. I have a few links over here which I want to show you, that what we have in our site that you can refer to as we go along. The first thing is the details about the Java training, the Java J2E training. I think this is the page that every one of us would have already gone through. So this is the MindsMap Java J2E training. The first page that anybody would visit. So
స్టార్ట్ అయింది క్లాస్ లో ఉన్నా ఇవాల్వింగ్ చేయాలి ఇప్పటి నుంచి బాయ్.
I'm sorry, I can hear somebody speaking. Please unmute if you are doing some of the call. So the Java J2E training, this is the first page that you could visit on the MindsMap site. Apart from that, there are some very useful links that you would have, like the one is the knowledge base, which is a very important link. There is something called a knowledge base that we have in our site. This has a lot of questions around a lot of different topics. This is actually the basic, the different tracks of training that we have. And the one that we are looking at is the Java and J2E. Today it's called Java Enterprise Edition. Of course, we are on version 6 or 7. But then all the questions, all the relevant questions that you need to go through, you would find in the knowledge base. You can also ask questions which will be answered by our tutors. So if you click on the Java J2E training section within the MindsMap knowledge page, you will get a lot of questions around Java that would be answered over here. So you can see that there are some questions around Spring MVC, Hibernate, Spring, what aspect-oriented programming, auto-wiring, and then there's a place where the trainers also post a lot of blogs around these topics. Apart from that, you have the online knowledge assessment module, which is more like a set of questions that you can use to evaluate yourself. You'll also use it for preparing for an interview. So say if you go to Java J2EE, um, you can see that there are different, there are different topics. So as and when we look into each of these topics, you could actually go into this section and then try answering the questions that you see over there. And if you have any doubt, of course, we can always discuss them in class. So there are a lot of questions that you can use to, evaluate yourself. So these are the assessment modules. And then apart from that, there are also some resume preparation tips that we have in our portal. So there are some very useful links that you can go through within the MindsMap portal itself, and we are continuously updating our portal. We are keeping it up to date with some of the latest questions that are being asked in the interviews. So they're going to be anything relevant to Java, J2EE that you want to know. You'll find it within the portal itself. And as we go through the training, if you have any further questions, you could always ask me, and I want us to keep it as interactive as possible. All right, so let's break the ice. Well, the first thing is I want to set the expectations right. So for all the people who are logging the call today, you just introduce your names and then let me know what is your expectation from the training. Maybe a little bit of background about yourself.
Hello, could you hear me?
Yep. Hi, I can hear you.
And could you speak louder? And there is some background noise.
Okay.
Thank you.
Is it any better now?
Yeah, just speak louder because I have my volume has already the largest. So
Okay.
Thank you.
Okay. Yeah. So what I want to know is what is your expectation from the training? So we're going to have it for the next couple of months. What we'll be looking at is core Java and enterprise Java. But what I want to know is a little bit of background about yourself and why you want to undergo this training and what is your expectation from it.
Hello.
Hello. Yeah.
Hello.
Yeah.
Oh.
There was silence, so I was not sure.
Yeah, please go ahead. I'm just waiting to listen from you guys as to what is your expectation from this training? Why do you want to join this training? And probably maybe you're looking out for a job, or probably you are already on a job and then you're trying to move on to a Java developer role, something like that.
And I want to be a Java developer, and I have some problem with the Java interview. So I hope this class could help me to practice the interview and help me be ready for that kind of entry-level Java developer interview. That's what I'm expecting.
Okay. Yeah, definitely we'll be covering a lot of interview questions as well, along with the concepts. Yeah, apart from that, who else do we have in the class?
Yeah, I'm Mukta, and I want to go for a Java certificate course. So that's my expectation is that after doing this training, I'm in
Yes, Mukta. We would be covering a lot of questions from the SCJP certification that you will be looking at. The Sun certified, what is today called the Oracle Certified Java Programming. Yeah. So we will definitely be covering a lot of questions, and this training is definitely going to help you in preparing for any of the certifications that you're looking at. So it could be the Java programming or any of the enterprise Java certifications as well.
Okay. Great.
And yeah, any other expectations?
Hi, I'm Shilpa. I had yeah, hi. I had completed my master's, and I want to learn OOPS concept completely because I believe when we know Java, we can understand any another language.
Yes. Yes, Shilpa, there's a very good point that you have made. If you learn one language well, then you can understand any of the other languages. Now, with all the languages that we have in the market, like we have Java, we have C#.NET, you can go for any of the languages out there. But then, if you had to pick just one, then you'd of course go for Java. There could be multiple reasons for that. One is the demand for Java in the market. And the second thing is, it's a very well-defined language. If you learn the features that you have in Java, then you can just understand any other language as well. So we'll be going through that in today's training. Some of the features of Java and all that. An overview of that. And anyone else who wants to share his expectations?
Well, I'm Srinivas from Dallas here.
Yeah,
well, the thing is why I want to learn Java. Back in the past, about 10 years, like I got about 18 years of experience in application development. Like I'm an ETL developer, EDW and all that stuff, Oracle and all that stuff. The reason with Java was I never had an opportunity to work with Java projects, and I want to move into big data and Hadoop. So what happened last year was I took some Hadoop and big data courses, but I really couldn't understand the MapR code and all that stuff because much of it is all Java. So there I had a problem, even though I was trying to learn the course, but it's all over my head because I had no background of Java. So I want to have Java 1 or 2 projects, learn. Yes, definitely I want to be serious. It's not like I want to be just touch and go. But once I learn Java, the basics, then I want to make a career in Hadoop and big data. That's my intent.
Okay, Srinivas. Yeah, that's.
The thing is, at this point, what's happening with me is my ETL development with data stage and all that. Like I'm looking for a breakthrough to grow up in career. So like I need. And when I look at the market, I don't know. I'm already getting outdated. I don't want to get outdated because if you see the job options, it's all Hadoop and big data these days. So yeah, in data warehousing especially, I mean the world is moving towards big data and Hadoop. And DevOps and all that, and Java is like now ABCs. It's now fundamental. Now it's like mandatory in those areas.
Yes, Srinivas. I completely agree with you. Being in the technical stream, we always have to keep ourselves updated and
So to break into that, I'm using Java as a bridge. Yeah, I need that. That's the reason.
Yeah, you will be able to understand all that once you get the basic concept.
Yeah, I understand the programming part, the coding part of it, but the thing is, I never had my hands on the projects and even last time when I took the course, it was not feasible. I took it from India-based team. I mean, there were connectivity issues and all that stuff. I was like, even though it was good, the guy was good, the institute was all good, but we had other issues. I mean, logistic issues and all that stuff. I hope you don't have it. That's what my intent is. No connectivity issues and all that, right?
No, we don't have those issues.
Okay.
Yeah, Srinivas, good to know. So the Java training that we'll be having, we will be covering completely the language fundamentals of everything, along with, we'll also be doing a project, a very live project, and we'll also be looking at some of the best practices around. So that is the track in which this particular training is designed. Just to be clear, we are not going to cover any of the MapReduce or any of the ETL techniques over here in this particular course. But if you want some pointers, I can give you that as well.
Yeah.
Because this is going to be a very interactive.
Yeah, Pawan. I mean, I definitely feel free to guide me for the big data and Hadoop. That's where my target is also.
Sure.
Yeah. Any inputs from your end, any links, reference links, and whatever it takes. Yeah.
Yes. Sure. That is why that's the advantage of having a training course like this, where we can customize our training based on the requirements, based on your requirements. So whatever core Java, the language fundamentals that we'll be covering is what you would be requiring. So once you understand the core Java fundamentals, then you will be in a position to, learn any framework or anything either for ETL or for web application development or for anything else for that matter. Okay. Any other expectations? Okay. Thanks, Srinivas, Shilpa, for for sharing your expectations. So let's go ahead, with the first eye view of the whole training.
Sorry, I was talking on mute. This is Kaustubh. I just wanted to introduce myself quickly. This is Kaustubh, and I'm basically working right now. I have 10 years of experience in IBM data middleware space. So basically working on WMB, data power, and WTX. And most of the times I feel like one thing that I'm missing is Java. So that's why I want to learn Java, because that's the base, as Srinivas was saying. So
Yes. Thanks, Joseph. And welcome everybody to today's session. It's like I think the expectation is pretty clear. Like everybody wants to learn Java here, basically the core Java fundamentals, and then more importantly, like how do I apply all these concepts and build a project on my own. And then I can see a couple of people here who want to go into different tracks. So it could be like you're getting into ETL or any of the other frameworks that you want to work on. So you'll also get pointers on them as well. So this training is split into 2 4-week components. So a total of 8 weeks is what we are looking at. Now it's not like it's not very strict, like we have to finish it in exactly 8 weeks, or this is going to be the last day, or it's not something like that. We'd always keep it flexible. We cover the concepts, the particular specific concepts that you want to understand more is what we'll focus more on. So that is why I want these sessions to be as interactive as possible. So as we go on with the training, you can always stop me. You can say, probably this is not something that you want to focus on, or this is something that you need more clarification on, and then we can discuss it further. So, we can emphasize on the concepts that you would want to understand and you would want to apply. So you keep it as practical as possible. Okay, so looking at the the whole training structure that we have, it's an 8-week training. The first 4 weeks is what we'll take to understand core Java. The core Java is what is the basic language fundamentals. And then the second part of it is focused on enterprise Java and some of the Java frameworks. So frameworks like Struts, Spring, and Hibernate, these are used for building web applications. So these are the 2 different modules that we have within the Java JE training track. And if you look at web application development, the most popular frameworks are Struts and Spring. Of course, Struts is losing its shine of late. Spring has completely taken over, but knowing a little bit of the fundamentals of Struts helps you in understanding Spring as well. And no matter which tier of the application are you working on, maybe it may be front end or back end or middleware, or whichever tier you're working on, you will always have some part of the Spring module that you can use within your project. And Spring is a very flexible framework, so that is what we'll be emphasizing on in the second part of this training, which is the second month, or you can say the next the last 4 weeks of the training. So so if we look at the agenda for today, today being demo session and the first day, it's like what we'll be looking at is an introduction to Java, basically historically why Java and the basic salient features of Java, and then how to set up your environment for Java development. As we go ahead, as I said, this is going to be practical training, so I'll be writing code, and I'll be explaining it to you as to the what is what of everything within the Java language. All right. Please feel free to stop me in case you have any questions. And for those who joined late, please make sure that you also put in your, you ping your email addresses and contact numbers in the chat window so we can contact you back. So, starting with the introduction to Java. So, we look at a bit of history of Java from a programmer's perspective. Okay, and then we look at some of the salient features and what are the major Java additions that we have in the market today. Now, without taking much of your time, let me just introduce you to the world of programming. I think a couple of you are already you're already experienced, so I think you'll already be knowing everything about the programming world and all that. But since I was not very much prepared for the same kind of audience that I have today, I'm just going through some of the generic slides for the introduction to programming that I have. So looking at historically, if we have to see where did all this programming or all these programming languages or computer science started from, we can trace it back to the European agricultural revolution that we have around 1700s. So it's like there were some advances, some technology advances when it came to agriculture, because we needed the basic necessity of mankind, which is the most basic necessity is food. So we need food to eat. Apart from food, we also need shelter and we need clothing. So if you look at the European agricultural revolution that started, we were able to produce more food in the farms. So and that created, that helped us produce more crops in the farms. And then we also had the industrial revolution that followed the agricultural revolution. That's because when farmers would produce more food, more crops, and then they needed to also transport it to some other location. So there were some some inventions around the transportation or automobile sector, as well as we also had some factories. So for clothing, we had a lot of the textile industry. There was a boom in the textile industry as well. So if you look at starting from the agricultural revolution and the industrial revolution, that age, we had the basic necessities of mankind being answered over there. So we had answers to clothing, we had answers to food, and we also had answers to shelter. So there were a lot of inventions around that time. But then if you look at, say, a specific factory today, if you go to a textile factory where people are manufacturing clothes, okay. So probably you have cotton as input, and then the cotton cloth that you have as the output of the factory. Now, whatever happens within the factory, that is the process that the raw material has to undergo before the final good is generated. It has to, there is a specific process, and there are a lot of machines that do that. Now, when you have to monitor those machines, when the processing is going on, say you need say for Levi's jeans, you need clothing that is completely uniform. Okay, you don't want to have any defects in your material. To monitor all that, you also need some machinery that would compute, how fast are the gear wheels rotating and all that. So there has to be some computation as well within your factories, which would need to be fast as well. So that was the evolution of computer science, and the initial computing machines are based on mechanical systems. If you look at the disk lighting that you can see in the middle, It's something that can be rotated, and it was a mechanical calculator that was used during that time. So if you input say 20 and then multiplied by 30, and you have to rotate it a few times before you got the output. So these were the initial mechanical systems, and these mechanical systems even work today. Whereas if you look at the electronic systems that today's computing machines are based on, these don't work. These don't work. These are not as durable as the mechanical systems that we saw, that we see on this page. These are systems that work even today and without any maintenance and all that. So why is that move to electronic systems? Why are today's computing machines based on electronic systems? For that, basically, there were two needs which led our computing machines to be based on mechanical, based on electronic systems rather than mechanical systems. And one was switching speed. If you use mechanical systems, um, uh, I'm sorry, but I can hear some noise in the background. So it would help if if you mute yourself and unmute yourself only when you have to speak anything, so it doesn't disturb the class. Okay, so looking at why we need why was the move to electronic computation systems from mechanical computation systems? It was for two reasons. One was the switching speed. If we look at the mechanical systems, they were probably switching at maybe 100 per minute, or a max of 1,000 or a few thousand per minute is the switching speed that we are looking at. But we know that the switching speed of electronic computation systems today is in millions of operations per second, and everything within your computer is like within the CPU or within the whole architecture that we are looking at, the hardware components. It's based on switching. So if you have to do any kind of computation, it's based on switching. If you want to store something, it's also based on switching. So it's either 0, 1. So it's like everything is based on switching. Now, the faster the switching, the faster is your computation. So with mechanical systems, the switching speed is very slow, and that's why we have to move to electronic computation systems. And then the second one is wear and tear. The wear and tear of mechanical systems, where you have to replace a few components, even if you are driving your car, so that always you have to give your car for service, and then they will replace certain a part of the system every few years. So whether it's a tire, whether it's your gear wheel, or any of the parts of the mechanical system is exposed to wear and tear. So when you have wear and tear within your mechanical system, you always have to keep replacing it. And that is something, that's the advantage of electronic computation systems, where there is no wear and tear over there. So everything is based on the movement of electrons. So electronics is nothing but mechanics of electrons, so electron mechanics. So I can still hear some background noise. Could you please mute yourself so you can continue with the class? Already. So I think if you have been through your computer engineering during your engineering, you will have already studied the basic modern computer system, which is all based on the von Neumann architecture. The basic von Neumann architecture has an input as well as an output, and and you need some space for storing all your data, and these are the different storage devices that you use. So based on certain input and certain programs that you have running on top of your CPU and using some main memory, you have it processes and probably reads some data from the storage device, and then it outputs. You'll see the output of that data on a monitor or a printer. So this is the basic von Neumann architecture. And then the CPU is again, I can still hear some check if there is okay. Yep. I hope I'm clear now. What I've done is like I have muted everybody, but anybody who wants to, speak can unmute himself and speak on the call. And please insert me if you don't understand or if you're not able to hear. So if we look at, we already have a CPU, right? We already have CPU, which is actually the brain of the computer system. Then why do you need an operating system? So the basic answer to that question. The basic answer to that question is that you need to be able to talk to the CPU in order to tell what kind of program that you want to write on top of that. You need to feed the CPU with certain instructions. So every CPU has its own instruction set, whether it's Pentium or whether it's any of the other CPUs. Every CPU has its own instruction set, and you need to be able to talk to the CPU through the instruction set. Now, if you look at the CPU instruction set, if you would have had a chance to at least look at 80, 85, 86, if not Pentium. The instruction set, talking to the CPU through its instruction set and programming at that level is, it's a very cumbersome process. You have to give very detailed instructions to the CPU. So you need something that is better. You can't, ask a user to just give him a motherboard with CPU without any operating system installed on top of it. How would you be able to, even talk to the CPU? You can't just ask him to feed, every time he needs to do even pi plus 2, you can't expect him to read the mnemonics, enter the mnemonics as per the CPU's instruction set and get the output. So there was something called an operating system that was built on top of it, with the basic operations like having Word documents or Excel sheets or the basic operations that you want to do on top of your CPU and with your, say, your laptop or your desktop is something that the operating system takes care of. So you write a file, it helps you save that file at a particular location. You don't have to explicitly tell where it needs to go and get saved. So these are some things that the operating system takes care of. Okay, so now we can see that the operating system is the interface between the user and the CPU. It helps you. Then why do you need a programming language after all? Now, why do you need something like Java or C, C++ or any of the programming languages? Because the operating system is doing almost everything. Yeah, the operating system is doing everything, almost, but not everything. No, it does almost everything, but not everything. So there are always a few things, few extra instructions that you want to give, and probably you just want to build an application of your own which handles or automates a part of some particular process. So if you look at that, you have the OS is the interface between the user and the CPU, and so you need a programming language to give to add additional functionalities to software, to give additional instructions, or maybe to write an application of your own, which is not completely part of the operating system. So the operating system does come with certain functionalities, but to add certain more functionalities to the operating system, you need something called a programming language. And the programming language is something that that you could use. So the initial programming languages were more cumbersome to write. The new generation languages are more human-friendly. It's more English-like. So as most of you already have some experience with some programming language or have some exposure, I think you very well understand that there are different programming languages out there. For example, you already have C, which is a procedural programming language, C++, or Java, which are object-oriented programming languages. Now, why do we have to write? We already had these programming languages. Why do you have to write another programming language like Java? You already have C and C++. So why do you need another language like Java? Everything has a business intent. Okay, every invention out there has some intent or In case someone has invented something which has not been of use, then probably we have even it has been forgotten completely. But Java was invented with a business intent, and there is something within C++, even though C++ is an object-oriented programming language, there was something which which was supported by Java but not by C++. So something that you could achieve with Java but not with C++. So we have to see what all that is, through the in today's class. So if you have to compare C++ and Java with C++ and Java, both are object-oriented programming languages, but there is a very a primary difference. The difference between Java and C++ is that Java is a write once, run anywhere type of language, which means that you have to write your program once and you can run it on any machine, on any platform. Now, what is a platform? A platform for a programming language would be anything on top of which it is running. So the platform for a programming language like Java or C++ is the underlying software and hardware. It is the underlying OS plus, that is the operating system, plus the CPU or the architecture that it runs on top of. So if you look at programming languages like C and C++, you have to write your code once, and that is called the source code, as you can see over here. So you have the source code which has the programming language instructions. This is what all the programmers write. So if you have written a C++ program, probably you save it as a .cpp file, and then you would have something called a compiler. That compiler compiles your source code into a language that your CPU understands, that your computers understand, because your CPU understands its own instruction set. It understands only binary code. If you look at the instruction set of any CPU, it's all mnemonics. And what are mnemonics? It's basically hexadecimal code, or basically it gets translated into binary code. So it's all machine language. It's called machine language or object code. So to convert your text-like looking language code like C++, maybe you have written a for loop, or you have declared some variables. So all that is like machine-like language, human-like language, right? So that is called the source code, the actual file, the actual program that you're writing. But that needs to be compiled into machine-level language or the object code. So these are basically the binary instructions that your computer can understand. And the compiler is that part of the, it's a special type of program that translates your source code into object code. Now, in languages like C and C++, you need a different type of a compiler for every platform. So if you're using say Windows on top of your Windows server, on top of your Windows server, and probably an Intel architecture, you would have a specific compiler for that. Now, if you want to run the same C program, then you have to copy your C++ program onto that new machine and then compile it on top of, say, you want to run it on top of Solaris, you have to again compile your C++ program on top of Solaris platform. So for every new platform, you have to compile the same code again. Now this could be a problem because you cannot ship your application or your product and just use it on top of any platform. You'll have to compile your application for the specific platform that you want to run on top of and then ship it. So that was a problem. So if you look at historically, Java from the early 1990s, after the World Wide Web or the Internet was introduced in 1992, they started coming up with the specifications for the World Wide Web. We knew that languages, programming languages are supposed to be portable as well. All the applications that you write should be portable, which means that we should be able to write it on top of different kinds of systems, because there are a lot of different kinds of systems that are connected to the internet. So to to be able to run your program or your application on top of any platform. That was basically the requirement for which Java was invented. So in those early days, today we are talking about IoT, we are talking about Internet of Things, we are talking about embedded systems, we are talking about every system being intelligent in itself. But this was not, there's not an idea that has come out today. We had this idea even in the 1990s, and Java was actually invented for certain intelligent home appliances. So we had coffee pots and lights. Today we are not calling it the Internet of Things, right? We are not calling it intelligent systems, or so you talk about connected cars, or with connected factories, or connected homes. We imagine things like, say for a connected home. So as soon as I enter my home, if it is night, then all the bulbs should glow. So, and when I leave a particular room, the light should be switched off by itself. So that's more of an intelligent home that we are looking at. So when I go and sit on the chair of my study desk, then my study lamp should glow, and then when I get out of that, the study lamp should get switched off. So these are these are examples of connected homes that we are looking at. Connected cars is more like, you have a car which could park itself, or which could, self-driving cars that we are looking at. So these, this kind of connected cars or connected homes and all that we are looking at, which are coming out today, or probably some of them may come by 2020. These are not, ideas that we didn't have in the 1990s. These are ideas from the 1990s. But there was still certain, there was a gap. So we didn't have enough of, advances in electronics was not just enough to implement whatever we were looking at. There was some, advances in device physics that was required for, for making all these feasible. So, looking at Java historically, it was primarily for putting all the intelligence into home appliances, and it was supposed to be the next hot technology. Gladly today it is, but it is for a different reason. It is for a different reason. Now, though it was for intelligent home appliances, it was, the invention was for intelligent home appliances. The best part of, what the designers of the Java programming language did was they introduced portability into the language. You write Java once and then you can run it on any platform. Okay, so the issue of portability, so how was it resolved using Java? So basically, the concept over here is, and this is a very important concept for the Java programming language. So how is the Java code independent of, the underlying architecture? So here we have the concept called bytecodes. Okay, so you write your Java source code. You can call it, you name it the .java file, wherein you are writing your program. You have to compile that Java code and you get something called bytecodes. Okay, and these bytecodes are platform independent. Now these bytecodes that it gets translated to are also binary files, but these binary files are something that can be read on by any platform. So how is the platform independence achieved? So why or how can I run my bytecodes on any platform? That is achieved by, every platform has its own JVM, or it has its own Java virtual machine, or you can say the Java runtime environment. So if you have the Java runtime environment on top of every architecture, so for Solaris I have my own JRE, for Windows I have my own JRE, for every platform I have a different JRE which is already installed on that machine, then it has the ability to decode these bytecodes. So all I have to do is I have to write my Java code, and I have to compile it into bytecodes. These bytecodes are also machine level languages which can, or you can say these are executables, which it is also called class files in Java. So these bytecodes are then shipped to your customer location and they can run it on top of any platform. The only necessity there is that on top of that platform they should have already installed something called the Java runtime environment, or something also called the Java virtual machine. We'll see what the difference is. So the JRE or the JVM is what is required on any system to be able to run your Java code. So there are two steps here. One, writing your Java code which is compiled to bytecodes, and then bytecodes are then compiled or run using the JVM. So the JVM again translates that bytecode into object code which can run by the CPU of that platform. So that is how the write ones run anywhere, which is also called WORA. So WRA. So write ones run anywhere is achieved using Java. So in Java, first it is translated to bytecode using the Java compiler. The bytecodes are shipped to different customer locations. The bytecodes can run on any platform. The only necessity is that on top of that platform, the JRE should already be installed. So this is just some slides which are explaining whatever I told. So the bytecode can be run on any type of computer. So basically it's a Java virtual machine that is responsible for converting the bytecode into object code again. So basically that any implementation of the Java virtual machine or the JVM is the Java runtime environment. Okay. So if you look at the issue of portability was resolved, but then there was a problem that though Java was invented for intelligent home appliances, the intelligent home appliances sector didn't pick up at that time, but there was the internet that was introduced, the World Wide Web that was introduced, and that is with the introduction of the internet or the World Wide Web is when the Java became popular. So 1996 was when the first version of Java was out, and today it's more than 20 years since Java was introduced. So any questions that you have over here? Any questions that you would have here on the issue of portability, or how Java is portable on the JVM, or what the JVM does, the role of the JVM, where the JVM is actually...
Can you talk a little bit of jar files?
Yeah, the jar files are nothing but Java archive files. You can look at them as zipped files which have your bytecodes. So if I'm writing my Java code, it is like a .java file, and I compile that code, you have a Java class file. And these .class files zipped together is nothing but a Java archive file or jar files. So it is a collection of your Java classes or your Java bytecode.
So they are a bytecode, am I right?
Yeah, those are bytecodes. So that is why.
So how does the object code look like? I mean, like, if I want to say, hey, this is an object code, or this is like, for instance, you said jar file is a bytecode. How does the object code look like?
The object code are machine level instructions. These are nothing but zeros and ones that you are.
Okay, got it.
So these are
binaries. Okay, binary codes. Okay.
Yes, these are binary files. Even your class files are also binary files, but these are binary files that can be decoded or translated into bytecode, and those bytecodes are the bytecode is translated into object code, and that object code is something that your underlying CPU can understand.
Okay.
So because of this kind of a compilation process, which is a two-stage process, we say that Java is portable. Now you may ask, like, even C++, if I needed a separate compiler on every, on every say platform, if I have a separate compiler, I have a separate compiler for C++ as well. So can I say that C++ is portable? The thing is, C++, you need to pass on the C++, that text file, that code itself. So, but here in this case, as we were talking about the jar file, I can compile my Java source code into executables like the bytecodes or the class files. I can zip them into a jar file and then distribute it to the customer. In certain cases, we don't want to, share our source code with the customers, or we would want to, convert them into, files that are not readable by the customer. So, and we also need to ensure that the code that we have written, it is fine-tuned. So all that fine-tuning also happens when the bytecodes are generated. So say you have written some Java code, and in your Java code, say you have declared certain variables that are not used in a program, for example. Your Java compiler is intelligent enough to not even use it in the bytecodes. So it also fine-tunes your code when it creates the bytecode, and these bytecodes are these are minimal in size as well. So, and these are then ported or shipped to your customer location, where they run it on top of any platform. So that's what makes Java a portable language. So any other anything else that is not clear over here before we move ahead? So if that is clear, then we'll move ahead and we'll see some of the features of Java. One thing is very similar to C and C++. Even Java is, you can say, it's as simple as C and C++, or be more simpler. It's like you can say it's a fourth generation language. It's like you can read it. It's more human readable. So it's not like some of the Unix commands that you have, which make it not readable, or it's like awk or grep or something that you do with on top of the Unix platform. You would have used any of the Unix command line tools. These are more human friendly. So if you look at a Java program, you'll be able to easily understand the whole flow or the whole logic. And it is very similar to C and C++, with the exception of some of its demerits. For example, in C and C++, you have the concept of operator overloading. You have the concept of multiple inheritance. In Java, you don't have multiple inheritance, which means that one class cannot inherit from multiple classes, and there is an important reason to that. We'll look at these concepts as we when we look at object-oriented programming in Java in the next class. But there is no concept of multiple inheritance in Java, but there is a way of achieving it in a much easier way and a much more well-defined manner. And then the go-to statement is eliminated. We definitely don't need go-to statements in any language. And if you have go-to statement, that there is a problem with traceability. Tomorrow, if you have a bug in your code, you don't know from which line did I even come to this particular line. So you have a line in a particular program which is pointing to which has a go-to statement, and that go-to statement is taking your execution to some other file and some other line in some other file, then it becomes very difficult to trace, and that's not a good practice. So even if you have go-to statement in any language, please don't use it. Go-to statements it's completely eliminated in Java. You don't have that concept. Header files are also eliminated. You do import certain, but you don't have something called the concept of header files the way you have it in C and C++. You don't have the concept of pointers, which is a big relief. In C++ you have pointers, but then it has caused a lot of security concerns as well. because you could point to any particular variable in any particular memory location, and if you have the memory location, you can as well read the variable. But that particular security concern you don't have in Java, so you don't have concept of pointers in Java. Basically, you don't need pointers. Automatic garbage collection is one more feature, which is a very good feature in Java. It's like when you are executing your application, the application creates a lot of different objects in memory, and that is how in object-oriented programming, everything is an object. You have classes of objects, and then objects get created in memory when the application is running. We will see all this in detail, but just to introduce you to that, in C++, even though these objects are created in memory, after your objects are used by the program and the program exits, okay, so there's continued execution, and it has created, say, object 1 and object 2 in memory, and now it is not using it anymore. In C++, you have to explicitly deallocate the objects from memory. Which means if you have object 1 and object 2 and you're not using it anymore, you have to say that object 1 and object 2 have to be removed from memory now. And if you forget to deallocate the memory in C++, it causes memory leak issues, which means that there are certain objects that are no more used by your program, but they are still consuming memory. How does Java resolve this? It is using automatic garbage collection. So the garbage is nothing but objects that were created but were used by the program, but now it is no more used by the program. So those particular objects have to be collected. It is auto-collected by Java. So it is auto-collected by the Java runtime environment. And then you also have a rich set of predefined classes. There are certain things like, for example, if you look at the different data structures and algorithms that are required, most of the major data structures and algorithms that you would need, say whether you want a list or a map or a different kind of a map, or maybe a concurrent map, maybe something that is thread safe, all these different data structures that you would need along with the algorithms for that, say for searching through an array, or maybe inserting into an array, or maybe reading from an array, deleting from an array, or maybe into a map or a set or a queue. There are a lot of different classes that are already well defined, certain collection classes that are well defined. You also have classes that help you connect to a different port on a different computer. You have classes that are already written which help you connect to a database. So you don't have to manually write that code. So all you have to do is call that particular API within your Java program, and it will help you connect to the database and run your SQL statements as well. So this is something that you already have, and Java in the last 20 years, it's so mature now. We'll also look at some of the latest features of Java within our during the course of our training, and certain things like the lambda expressions that you have, functional programming within Java. These are very powerful features, so we'll also look at them in due course. Okay, Java is object-oriented, so it's an object-oriented programming language. Everything within Java is an object. It's a before object-oriented programming languages, we had something called procedural programming languages, where everything was more like a method or a function. So even if you have to write a calculator, you have to write an add method. You have to pass certain parameters to that. But then within Java, you define a class called calculator and create an object of calculator, and it has its own attributes. And this is something that we look at when we look at object-oriented programming in Java, and why object-oriented, and what is the significance of programming using object-oriented languages, whether we should be using object-oriented language or should we go for a procedural programming language, which one should be used when. Now, there's nothing like, one is better than the other. The complete statement would be one would be better than the other in a particular context. So we always have to look at a particular context. In a particular context, an object-oriented programming language may make more sense than a procedural programming language. And then it is very robust. It is very robust. So Java, in most of the cases, you cannot make mistakes. Okay. In some languages, if you write, say for example, you take a language like JavaScript. Please, for those who who don't know already, the JavaScript has got nothing to do with Java. JavaScript is a completely different language which has a name something similar to Java, but it is not Java at all. JavaScript is a totally different programming language. The relationship between Java and JavaScript is no more than the relationship between Java and C++. Like C++ is a different programming language, JavaScript is also a different programming language. Java is a totally different language. It's there's a lot of confusion within the industry, especially with people who are not using Java. That JavaScript is something like a subset of Java or something like that. That's not true. JavaScript has got nothing to do with Java. Now, if you look at the JavaScript programming language, it's not robust. You can make mistakes and you will not even know. You can introduce bugs and you will not even know. You can have errors, you will not even know. But Java is a very robust language. If you have done, say, if you have written some program which is dividing, say, something like 4 divided by 0, okay, it has something called exception handling which you can use easily to catch something. You can catch those exceptions and you can write code and tell what should it do when it finds an exception, and it's very robust. You cannot go wrong. And you have automatic garbage collection also, which prevents memory leaks, so you cannot go wrong with deallocating memory, because you don't have to deallocate the memory. Java takes care of that for you. You have type safety of data. Java, when you're writing code with Java, you always have to specify the type of the variable when you're declaring it. Unlike JavaScript, in JavaScript you just have to say where a is equal to 1, 2, 3. So a becomes a variable. So it is supposed to be an integer variable, but you cannot specify that it is an integer variable. But in Java, if you have an integer variable, you have to say int or integer. And if you want a string variable, you have to specify string. So it is all type safe. Okay, and there is extensive compile time and runtime checking. Both at compile time and runtime, there is extensive checking that is done. Now, all the features that we are talking about, we are going to look at it in a lot more detail. Now, object-oriented exception handling, say for example, your divide by 0 exception that I told about. So, when we are writing code, we just don't write for the main flow. There is also a main flow of, say for example, you're writing code for dividing two numbers. So, the normal flow would be input A, input B, and return A divided by B. That is the normal flow. But what if there is an exception? What would be the exception be? The exception would be if somebody enters B as 0. So then you can't just return A by 0, right? Say he inputs 3 and 0, then you have to return 3 divided by 0. What is 3 divided by 0? We probably don't know, right? It is probably tending to infinity, but we don't know. So in that case, that is an exception to the normal case. The usual case, the normal flow of that particular piece of your code would be return A divided by B. But if B is equal to 0, then what you have to do is something which can be easily caught using something called exceptions. We'll also look at exception handling in Java later. Then it is also architectural neutral and interpreted. It is write once and run anywhere. What you need for that is a Java runtime environment which is installed on every machine. So whether it is a Solaris or a Linux or a Windows workstation, based on which workstation it is, an appropriate Java runtime environment needs to be installed. Your Java code, which is your Java file, has to be compiled into what is called a Java bytecode, or it's a class file, and that class file is then shipped to each of these. And the same class file is the same bytecode, or if the class file is zipped into a jar file, that jar file can be executed on any of these workstations. That is why it is architectural neutral, and it's highly portable. The other features that make Java powerful, it has API that takes care of networking, which means that if you have to connect to a different machine, to a different port, to a different socket, you can do that. It has the concept of threads. So if you want to make your, if you want to use, you want to do multi-threaded programming, if you want a particular piece of code to run parallelly, say for example, you have multiple files, multiple Excel sheets from which you are reading records. So if you have 4 different Excel sheets with each of those having 10,000 records each, and you want to just make it faster, so you just have one piece of code which is reading each record and then inputting that into the database. So what you can do is you can make your code have multiple threads. So the same piece of code will have, say, 4 different threads which are acting or which are working on all these 4 different files. So each of these threads is reading from the files independently. So instead of taking 4 units of time, you can finish it in 1 unit of time. So instead of 4 minutes, you can finish it in, say, 1 minute. That is why you use multi-thread programming to make your execution faster. Then you also have the concept of distributed objects. That's more to do with distributed programming, where in a distributed environment, which is more often than not in today's date, it's like you have distributed objects as well, where you can access one object from another. And then you have a database. You have code that can be used to access the database, and you also have code or the API within the Java library that you could use to create some wonderful graphics. Okay, and you also have different data structure collections library where you could use it for creating your own stack, heap, or any of the other data structures that you would want to use in your. And you also have API that automatically serializes your objects for you. Serializing is, whatever object, whatever data you have within Java is inside an object. And say you have read some particular object and that object needs to be sent to some other server on a particular machine or to the client. You need to be able to serialize it. Okay. So that data that you have as an object, you can't just write that data or send that data or that object as it is. It has to go through the physical wires, isn't it? But when you are sending an object through the wires, it has to go in as zeros and ones. So that serialization is nothing but the process in which you are converting your objects into a format in which you can transfer your object to another recipient. That recipient could be a client or a different server. You would also want to store your object in a particular, say, file. So if you have to store your object or save your object in a file, for saving an object into a file, it only understands zeros and ones. So finally your object also has to get saved in as zeros and ones. So that is also, for that also you need serialization. So serialization is the process of converting your objects into zeros and ones or in a format in which you can either transfer that object or save that object in a particular file. And then you also have certain features in the Java language that takes care of digital signatures. Okay, and then it is of course very popular. You can see that it is it's the most popular language today compared to any of the other languages, C, C++, C#, PHP, or JavaScript. You can take any of the languages. Java is the most popular and is the most successful today. So you work on any tier, you have something, some API or some framework, some Java framework that you could use to use to. So you could use any of the APIs, any of the Java APIs or any of the tires. So that's why Java is very popular, and for all the other features that we saw. And apart from that, yeah, it is distributed as well, which means that basically, if we are programming for the internet, that program has to interact with clients and it also has to interact with servers. So there are certain technologies that we look at later within Java that helps your code to be distributed and to run in multiple places as well. Okay. Then, as I said earlier, it also supports multi-threaded programming or parallel processing. There are three major Java editions. Java Standard Edition is the one that is what we call Core Java. It is the one that is used for building desktop applications or applications that just run on your desktop, which don't have to interact with any other machine on the internet. It could be a server or it could be a client or anything. But if you have to build a web application or something that runs on the internet, then what you would need is the Java Enterprise Edition. So, and then there is one more edition called the Java ME, which is the Java Micro Edition, and this edition is used for programming. This has certain APIs that are more for the mobile use case. Now the third, which is the Java ME, is not part of this course, and that's not highly, it's not something that is very much in demand in the market as well, because there are a lot of other technologies which can be used for creating responsive web applications. There are a lot of JavaScript libraries as well, which are very popular today. But the Java SE and the Java EE, both of these is what is part of this training. So the first half of it is going to be Java SE, which is the core Java part, and the Java Enterprise Edition, or the along with the other frameworks which are built on top of Java EE, like Spring and Struts, is what we'll be looking at in the second half of this course. So we looked into the history and the basic salient features of Java. The first thing that we have to jump at, and before we meet in our next class, what we have to look at is the basic setting up of the environment for Java. The best part of setting up if your environment for Java development, or the different toolkit that you would need for Java development, everything is available free, and most of them are also open source. But most of them are free. So what you would need is the Java runtime environment for running your Java applications. But as you are a Java developer, if you want to go develop some applications, then you will need the JDK, which is the Java Development Kit. So the JDK is nothing but your Java runtime environment along with other tools that you need as a developer. But if you are shipping it to your customer, and if your customer asks what does he need for running your Java programs, all he needs is the JRE, or the Java runtime environment. But you as a Java developer would also need the JDK, which is a superset of the Java runtime environment. So how do we set up the environment, and what are the tools that we would need? The first thing is the JDK. The JDK is available free of cost from the Oracle site. Earlier it was part of Sun Microsystems, today it is part of Oracle. The JDK, you have to download and install the latest JDK that is available on the Oracle site. JDK is nothing but your Java development kit. And then the second thing that you would need is Eclipse. Eclipse is an IDE. It is an integrated development environment, or basically the tool or the workbench, as you can call it, for Java development. So if you download Eclipse, then you can start developing any of the Java programs. It helps you write, so it has certain text editors and all that, where you can input your Java program, and it also helps you compile and run those Java programs and test it within the environment itself. So these are the only two things that we need to start off with: the JDK which is available on the Oracle side, and Eclipse. Now, the difference between JDK and JRE, as I mentioned, is that the JRE is something that you need to run Java programs. Okay, so if your customer asks what is it that you need, or what do I need in order for me to run the Java program that you have shipped to me. So you wrote your Java program, you created the class files, and you are now sharing those class files with your customer. What does he need for him to be able to run it is nothing but the JRE, the Java runtime environment. He doesn't need the JDK. Of course, if he has the JDK, he'll be able to run it. But you as a developer, you need the JDK. So how to download and install the JDK? We have the instructions in these presentations. The format in which we will be having this training is that you don't have to take any notes. As I'm saying, you have the recorded versions of each of these training sessions. Okay. So you will have a recording of these, as well as you will have the presentations available with you. Okay, so you can go through the presentation, you can listen to the presentation again, and at the end of every session, except for today's session, starting from next session, we'll also have exercises attached to every session. So today was just an introduction.
So tomorrow will you be giving us the downloading, how to set up the environment and all that? Is it the way, or how do we do
it? The instructions are given here. And it's like I'll be sharing this PPT along with the links. So if you go to those links, it's just a site where you have a link, and if you click on that link, it gets downloaded. And along with that, I'll give you all the instructions that you need to follow.
Okay.
So it's like, see, for downloading and installing the JDK, starting from step 0 to step n, you have everything that needs to be done. So first you have to download that, and then you have to, create the path. So you have to make an entry into the path environment.
Okay, yeah, this is what I was looking for. Those is set of all those every detailed instructions.
Yeah, so you'll get all the detailed instructions. And in case you still have, issues with any of the instructions over here, though these are instructions that we have shared with all the previous teams as well. So we have not found any issues with this. But in case you have any issues, you can always write to us. So if you write to us, Surendra will share the email address to which you can write, and then we'll answer any of the doubts that you would have in the previous class, or you can always reach out to us on that email address.
Okay.
Actually, I'll be the person who will be replying or responding to your queries on that email address.
Okay.
So each and every instruction will be given, and for certain things like this, I'll be giving you the instructions. In case you are still not able to do it, we can, in the immediate next class, I can show you as well as to how to do it.
Okay.
And especially the programming part, it's not going to be theoretical in nature. Of course, we'll be covering the theory, but we'll be focusing more on the concepts. And as two of you are very much experienced, I think we'll have it would be better if we focus more on the practical, practically where we'll be using and which of the APIs is more important, and focusing more on that, and everything about the basic language fundamentals is what we'll look at, and from a very practical standpoint. So I already have Eclipse and everything installed. So what I'll do from next class is, like, as I go through the concepts, I'll also open up Eclipse and I'll write in the code, and I'll explain to you each and everything that you need to know even within the Eclipse environment. So that is basically the format of the training. And after we finish, after I show you some examples in class, I'll give you a set of exercises that you can try out. And so you can try it out, and if you don't get the solution for that, I'll share the solution with you in the next class. So, and if you have any doubts from the exercises as well, that can also be discussed in the next class. Apart from all these, we also have a couple of sessions where we'll just be looking at certain interview specific questions. So if you are attending any interviews, so what are the concepts that you have to look at? So we'll have some interactive sessions where we're looking at the different questions or the different topics that need more focus from an interview standpoint. And we could also look at, especially for those with less experience, probably we could also look at how to write your resumes around Java development. And in the end, we'll also actually be doing a live project that needs to get implemented somewhere. So that particular, you'll get that live project experience as well. And it's going to be, we'll do all the code reviews and everything that we need to, for the way we do it in any other organization or any other company. We'll also be looking at the best practices around that. So it's going to be very practical in nature. So there are instructions on how to download the JDK and from the Oracle site, and then what are the different steps that you may do, and then also which version of Eclipse would you need and how to download and install it. So this is something that I'll be sharing with you. So this is for today's session. So we can, if you have any feedback or if you have any other expectations, I think you got the format in which the training is going to go on. So if you have anything, you can always, please stay interactive. Please speak up and let me know if you have any doubts or you want to change something, you want more focus on any particular topic, or maybe you want to look at more examples. We can always have that. There's nothing like, though the session, this training session is for 8 weeks. It's not like, it has to get over in 8 weeks, or on this particular day I have to complete something and that's why I'll rush through that. No, that is not going to be like that. We'll go at a pace at which you are comfortable, because in the end, whatever KT is going on over here through the, through these training sessions, the KT has to be successful. The knowledge transfer has to be successful. So basically, in the end, you have to understand finally as to whatever you came to this training sessions with some requirement. Those requirements have to be fulfilled. So whatever requirements you have, that has to be fulfilled, rather than me just going on with all the topics that I know. It has to be more from your perspective. So please keep this session as interactive as possible. And you can always write to me. You can contact Surendra. He will also share the email address. And please share your contact numbers and email addresses if you haven't already in our chat window, so I can share it with Surendra as well. He'll be the person who will get in touch with you. Okay. Any other questions that you may have, or anything that needs to be discussed before we disperse for today?
So what is the topic for tomorrow?
In the next session, we'll be starting off with the basic Java language fundamentals, and we'll also be focusing on object-oriented programming.
So do you want us to download, do the environment setup from our end, or will you be guiding us?
It would be good because we'll be sharing the slides, so it would be good if you can install the JDK and the Eclipse. Whatever you were not able to, I can guide you through that as well.
Okay.
So I want you to try this out based on the instructions over here.
Okay.
Because finally the thing is, even in the previous batch, what I wanted to do is, instead of telling you each and every step, I want you to get familiarize yourself with doing that.
Okay.
Familiar yourself with the environment, because when you are doing it yourself, you may make 1 or 2 mistakes, and then you will try to rectify it. That is when you will understand the importance of that. If I list everything down, then probably you will not get it. But then, if you're not able to do it, just drop me an email and we can, connect. And in the next session, I can show you in detail, each and every step. Okay.
Okay.
All right. So So, so that was it for today. So, thanks a lot, everybody, and let's hope we meet in the next session. I hope you have already, shared your email addresses in the chat window. I have Muktaz and Lulu's address. How about